Hey guys, welcome back to Consistent Code. So today's problem of the day is modify numbers in queries. So basically we are given two numbers, L and R, and what we need to do, we need to just um, find the we just need to find the sum of the prime factors of the numbers in this range. For examples, if L is 1 and R is 2, then we need to find for example 1, the only prime factor for 1 is 1, or and we need to consider one only for one only, and for other numbers we are not going to consider one because one is not a prime number, it's actually a unique number. And for r equals to 2, we are having the only prime factor as 2, or and for and the range is 1 to 2 only, so we will be having for 1 will be represented as the sum of its prime factors as 1, and 2 will be represented as the sum of its prime factors as 2. So our answer will be the sum of all of them, that is 1 plus 2, that is 3. Similarly, you can consider this case when L is 1 and R is 6. So 1's prime factors will be only 1. For 1, it's a unique case. And for 2, it's only 2. For 3, you can see it's only 3. For 4, it will be 2. For 5, it will be 5. And for 6, it will be 2 and 3. So 6 will be represented as 5. And hence the total sum which we will get will be the sum of all of these numbers in this range. And hence we get 80. Now how to solve this problem? So first of all, if we look at the constraints, then R can be at max 10 to the power 4, right? So since this thing is dealing with prime numbers, we should think of two things here. First is Sieve of industrial themes. And the second thing which we need to think of is prefix suffix arrays. Now, how to solve this problem? So since the constraints are very less, that is only 10 to the power 4, we can just create an array of size 10 to the power 4 to store the representation of number in this range in the form of some of its prime factors. So what we will do, we'll just create a global array sum of size 10 to the power 4 plus 1. And we will also be creating a global variable check, which I'm going to initialize as 0. Now, what I'm going to do and to solve this problem, I will first check if the check variable is not checked, then I'm going to make it as check equals to 1. And then I'm going to pre-calculate all for this range or 1 to 10 to the power 4, thus representation of that number in the form of some of its prime factors. Now, once we're done with this, all we need to do is just add this in our answer. So let's say that our answer is 0. We'll be defining this function pre-calculate once we are finished with this. So we have initialized our answer as 0. Then we will just move on from I equals to L till I less than equals to R. And all that we need to do is increment the sum of I, that is the representation of I in the form of sum of its prime factors in our answer. And that's it. That's all that we need to do. And then we will return our answer. And the only thing left for us to do is to pre-calculate the pre-computation thing. So first of all, we are just gonna set the memory of our sum array. So we will just use a memset function, and then we will be telling it the array which we want to set the memory, that is sum, the value which we need to set, and then the size of that array. Now the sum array should be initialized by 0. And now what we can do, we can just say that sum 0 will be 0 and sum y will be 1, because these are not prime numbers nor composite numbers, so we can just exclude them here. And then we can just say that sum of 2 will be also 2. And now I can just see that for the prime numbers, let me just create a vector to check if a number is prime, and let its size also be 10 to the power 4. And let me initially assume that all the numbers are prime except 0 and 1. So I'm going to consider them, so I can just mark them as 0. That means they are not prime. Once I'm done with this thing, the next thing I need to do is just observe one thing, that in the prime numbers, we have 2, 3, and 5, and so on. The only even prime number is 2. So first let's go with this even prime number 2 and make the code for that. And then we will consider all the odd prime numbers. So we have already considered is the sum of 2 as 2. Now we need to do this for all of its factors. So we can just run a for loop for int I equals to for all its multiples of 2 till 10 to the power 4. Then we will go to I into 2 less than equals to 10 to the power 4. And then we will just increment I by 1. And what we need to do now, we are just gonna mark the sum of this 2 into I should be incremented by 2, because every multiple of 2 should be having a prime factor as 2. That means that we need to have 2 as 2 in the prime, in the sum of prime numbers of that number. And after this, we need to deal with all prime numbers. Now, let's start by int I equals to 3 and I less than equals to 10 to the power 4, and I should be incremented by 1. Instead, I should be incremented by 2 because we have already taken care of all these even numbers. Sorry, here it should be incremented by 1. Now, in this thing, we just need to consider that if this number is prime, if the I is prime, then only we are just gonna go inside this loop and mark all of the multiple of this prime number as first of all, since this number is prime, so we are just gonna mark the representation of this number. Sum of I should be having I should be contributed in the sum, and then we just need to deal with the other multiples of this prime number. So we are just gonna run a loop for j equals to 2 and j less than equals to, so not j into I less than equals to 10,000, and then j plus, and yeah, here it should be I plus equals to 2 because we have already taken care of all the even numbers. So we are just gonna mark this I into j as a composite number that is not prime, and in this I into j we should have the contribution of this I. Great. So now that we have done this, we are having the fun representation of numbers 10 to the power 4 in the form of some of their prime factors. And I think that should be it. Now let's try compiling and running our code. So there is one error here. Okay, so the error was that we forgot an equal to sign when we need to add this representation of that I in the form of some of its prime factors in the answer. We forward to n is equal to sign. Now let's try compiling and running our code and see if this is working. So everything fine. And now let's summon this code. And we have solved this problem successfully. And I hope you liked this explanation. And if you did so, make sure you hit the like button and subscribe to the channel. And I will see you tomorrow with the next problem of the day.